Good morning, everyone, and happy Wednesday to you. I hope you are well. And on behalf of my colleagues, I would like to say thank you for joining us for this, the third installment of events for National Manufacturing Day, as hosted by Catalyst Connections in collaboration with Penn State New Kensington and the Digital Foundry at New Kensington. My name is Alyssa Pistoninzi, and I am the operations manager for the Corner Launch Box, which is Penn State New Kensington's entrepreneurial support center and co-working space. And I am also the business operations manager for the Digital Foundry. And I am very happy to serve as your MC for today's program. We have several distinguished guests joining us today, but before I make the introductions, I do want to announce that this session is being recorded for those unable to attend live. Next, we would like to share a short film as a way of showing our appreciation to manufacturers everywhere and the commitment they showed during the very trying time that we now know as the COVID pandemic. Thank you very much for all that you have done.
During a time that tested the dedication, determination, resiliency, and reliability of companies and employees everywhere, manufacturers of Northeastern and the northern tier of Pennsylvania never backed down. Instead, they doubled down on their resolve to fight the COVID-19 pandemic. Some pivoted and innovated their ways into new markets to provide our country with much-needed safety equipment, medical device components, cleansers, sanitizers, and personal protective equipment. Others enhanced their safety protocols and ramped up to keep products on shelves, technology at our fingertips, shipments on the roads and rails, medicines nearby, and external threats at a distance. Our regional manufacturers were the stronghold that kept us healthy and safe while keeping our economy running. It's no surprise that our manufacturers had our back during the pandemic. After all, we hail from communities and families that fueled the Industrial Revolution, forged the iron and steel that built our nation, and worked the land and harvested the yield for generations. Now, that ingrained work ethic is coupled with advanced technology, connectivity, diversity, and collaboration, and our manufacturing potential is limitless. We're not out of the woods yet, but our industrial engine is still running strong. And we're confident that our manufacturers will continue to lead us through whatever challenges await. Today, on this National Manufacturing Day of 2021, we pause to say thank you to the manufacturers that have healed, protected, nourished, energized, maintained, and comforted us over the past year, and their 44,000 regional employees. Please accept our most sincere thankfulness and gratitude for jobs well done when we needed you the most. Happy Manufacturing Day. We appreciate you.
All right, and thank you again to all of our manufacturers. And now I would like to introduce my colleague, Colleen Smith, who is the STEM Outreach Coordinator for Penn State New Kensington. And Colleen will tell us a little bit about the ABC Create initiative. Colleen?
Hi. As she said, my name's Colleen Smith, and I work at Penn State New Kensington as I call myself the STEAM Outreach Coordinator. So that's one of the things that has kind of evolved, and that's what I want to talk to you about is about ABC Create, is the way that education is evolving and how we are supporting that in our communities. About 7 years ago, ABC Create was formed, and it's 14 school districts in this region, the Allegheny Valley outside of Pittsburgh. And they formed because they recognized that change was happening all around us. And, we just saw that video that really brought, some visuals to the changes that we're all experiencing. In the video, at some point you see the steel mill, and you get the notion of, they talk about kind of the history of manufacturing real quickly there, with building on the backs of the physical labor that manufacturing used to be. And manufacturing has changed. In that video, you see some of the steel being poured, and you got to get a sense of that. And then you see in the same video, and a couple seconds later, there's real high tech environments. They're real shiny machines that are running and clean, and it brings to mind to me, how manufacturing has changed and how our world has changed. I think about, manufacturing in terms of cars in the assembly line and Model T Fords, and how we learned to make cars in a way that was efficient, that made them affordable. If we could get them off an assembly line, we could do it more quickly, we could do it more efficiently, then more people could have them and we could get more out. And that's how our world, not just in manufacturing, but in other ways was functioned for a long time, but we continued to change and evolve. And we moved forward. If you think about cars, and if you think about those cars, I go back to the images of watching the Waltons and looking at some of the old vehicles there. You know, some of them didn't have windows very well, and they weren't real sturdy, but you begin to see how cars got electric windows up and down, and we began to see those changes. And you think about how cars were made and how those assembly lines became more automated. So people were still managing them and doing much of the work, but it became something where computers began to pick up parts of that, and the people learned to manage the computers. So if you move forward even a little bit further into what we are experiencing today, and what cars can provide to us, they can park for us. Some of them can drive for us. They know how to tell us when they're sick and they need help, they need to be repaired. We can communicate with something like OnStar that lets somebody know when we need help from our vehicle. Those kinds of technologies that we have moved toward show the advances into things like the Internet of Things and cloud computing, so that we are collecting information, using sensors, using that data that we've collected to inform repairs on vehicles, to inform how we might get help and how the cars operate. So if you take that kind of process in history and you bring it to schools, if you look back at schools, the way we were teaching students was to learn how to work quietly, efficiently, and to stay at the tasks as they were provided from the teacher directly to the student, and the teacher gave the information out directly. So if you think that kind of mirrors what's happening on an assembly line, these are the parts, this is how it has to be built, there's one way to do it, we all do it the same way, and let's rock and roll and get these cars out there. If you move forward now, what we're looking at is, how do we use information that we come? What information do we need? What will that information tell us? How might we make changes as a result of that information? So when I think about the cars, we can use some sensors to determine that a part is beginning to wear, and we can report that out, and then we can communicate that out to say, yep, this part needs to be repaired. You better get your car out to the garage. That kind of work and thinking to get into place, we needed to look at how we were helping students to learn then, because in order to function in a world that works like that, we need students, we need learners. And that's a terminology. As education is changing, right there is a term that has changed. We're talking more about learners than about students. Students gives you the idea that there's a teacher who tells you information, you take it in, you study it, and you're able to get it back out. But what we want to encourage in education now is learners. How do we help students to be independent, to be creative thinkers, to be innovative thinkers, to keep up with the kinds of ways that we are working and the way the technology leads us, and the way we want to lead technology. So ABC Create formed and acknowledged that we need to make some changes in the workplace. And some of the things we need to do are to help teachers to recognize what's happening beyond their classrooms. So ABC Create brings teachers together for professional development, for teacher trainings, and we provide opportunities for them to learn more about technology. Many of the teachers today have never learned anything about coding or computer science or anything about robotics. And teachers often teach the way they were taught. So they were taught with information coming to them, they would study it and bring it back out. So now we are teaching teachers how to be better learners in their way to model it, and how to help students to be learners. So what does that look like for potentially you in the classroom? That looks like some experiences that our teachers would be bringing to you, like Hummingbird Robotics kits or Finch Robotics kits or Makey kits, and the kinds of things that allow you to learn about technology, to allow you to learn how to make something, how to make something think and act and do like a robot, how to use sensors, and how to program it to have the sensors that data from the sensors input and then have something come as an output. It also has other ways we are working with teachers is to help them to think about what are the characteristics we need from our learners. We need our learners to have a growth mindset. We need our learners to be able to say, you know, I can't do this yet. Not, I can't do this, or not, my brain doesn't work that way, but instead, I can't do that yet, or I don't do this well yet. And to recognize that the way our brains work is with effort, with practice, with coming at something from a different angle, from thinking it through again, from getting support and help, from collaborating with other people to help us to figure out how to learn. So encouraging that growth mindset is absolutely something that our teachers are bringing back into the classroom. Helping teachers to help our learners to develop a technological fluency. And that means not just that they're going to teach you how to use a piece of technology, how to use an app on a phone to learn how to do math, but to begin to think about how can I use that app and how can I begin to create with that something that will help me to solve problems. So we want our students to be thinking about what problems need to be solved and what they can do to solve them, what tools they might need to be able to solve those problems. And by tools, it could be a technology, but it could be a mindset. It could be an attribute. It could be, how can I ask questions? How can I bring people together who have various perspectives and diverse ideas and experiences to help to resolve a problem? So we want students to work in those ways, to develop what's thought of as an entrepreneurial mindset, so that you're thinking in those ways with that independence of mind, that desire to continue to learn, that understanding that change happens everywhere, and that when we embrace change with innovative thinking, creative thinking, and that's why I'm going to come back around to, we look at it instead of this STEM, science, technology, engineering, and math, with STEAM, with science, technology, engineering, arts, and math, because we recognize that it takes all of the brain, all of the ways that the brain works, and all of the attitudes and mindsets that we want to encourage in order for us to continue to navigate change in ways that will help us to thrive and to be successful. So not just for ourselves, but for those that we help to support. So that's what ABC Create does. And I think that'll help you to see how it begins to tie into manufacturing. So I'll hand it back over to you, Alyssa.
All right, thank you so much, Colleen. And now we will welcome our panelists. Thank you all for taking the time to be with us today. And I guess we'll just start by diving right into those questions. So to start off with, could you please tell us who you are and what you do and how you got to where you are today? And I will call in no particular order. I think I'll take a note from Steve and go for the first people that are on my screen. So Scott and Dave from Hamill.
Okay, thanks, Alyssa. Let me share a screen here. As Alyssa mentioned, we're going to introduce ourselves here. My name is Dave Houston. I work at Hamill Manufacturing. Hamill makes a wide variety of equipment for the U.S. Navy, primarily aircraft carriers and submarines. Our products range from a variety of different functions on those ships. The details, unfortunately, I can't go into, but we do serve the U.S. Navy. I am a manufacturing engineering manager here at Hamill. I started my manufacturing journey, I guess you could call it, right out of high school. My high school was standard. I didn't go to a vocational school. I went to the Greater Latrobe. When I graduated, I went to Pennsylvania College of Technology, where I received a 4-year Bachelor of Science degree in manufacturing engineering. After that, I pretty much graduated in 2010 and was hired here at Hamill. And ever since then, I've been working as a manufacturing engineer, where we look at our customers' drawings, requirements, develop processes to machine the parts they're looking to have made. Most of our parts we deal with are metal, for lack of a better description, a lot of stainless steel, a lot of Inconel, which is a high nickel alloy. So tough to machine stuff. We do welding in-house as well. So in a nutshell, that's what Hamill does. My colleague here is Scott Ankney. I'll allow him to introduce himself and give a brief background as well.
Hello, as Dave said, my name's Scott Ankney. My title here is manufacturing engineer. So part of my job function is to quote the materials and subcontracting efforts on proposals coming in the door. And also once the job is awarded, part of my function is to generate the job travelers, which is a step-by-step process that shows how the part is manufactured, whether that's a turning center or a milling center, whether it goes outside these walls for subcontracting and things like that. How I got started in manufacturing, I've always enjoyed either making or fixing things. I did attend VOTEC in high school, which led to a co-op. During that co-op, I was hired here at Hamill, so I would go to school half a day and come to work half a day. I started a 4-year apprenticeship program with the NTMA Pittsburgh chapter, where I earned my journeyman's papers. Due to my performance in school and on the shop floor, when an opportunity arose here at Hamill for a manufacturing engineer, I was chosen for that position, and that's where I live today.
All right, thank you, gentlemen. Next, we have Anthony Joya from Premier Automation.
Hello, hi everyone. My name is Anthony Joya. I work for a company called Premier Automation. We are a systems integrator, and that means that we program the machinery that is in mills. So all the things that Colleen was describing in her introduction are the types of things that we program, make certain devices communicate with each other to have our end goal is to have a up and running, ready to function machine. So our company also provides electrical control panels. So when it comes to controlling machine, you need to convert your signals to different formats and work with different voltages. And sometimes that isn't all built onto a machine. So we provide a control panel that you place at the manufacturing environment that'll hold your controller, which is a computer that will take in signals, send out signals to control different parts of machinery. Our company has 3 parts, 4, I guess. So we have an automation group that focuses on programming controllers and doing operator panels, which are like screens that people use to control machinery. We have a drives group, which a drive is a component that is used to control a motor. We have a robotics group. Everyone knows what robotics are, so they do robotics programming and design robotic cells. And then we have a build to print panel shop. So we create the electrical control panels that I mentioned before. I myself am an automation engineer and our research and development coordinator. So that means I'm one of the people that goes into the manufacturing environments and programs the machinery for customers. And then my R&D coordinator role is mainly around working with government entities to try to win R&D money to do R&D related projects. Well, I started, in high school. I always loved math and science. I went off to Penn State main campus to become an electrical engineer. I got a job at Siemens, which is a big automation component distributor. And then I decided I wanted to dive a little deeper in the engineering side. So I went to work for Premier, which is a systems integrator.
Nice, thank you.
Thank you, Alyssa.
And next we have Jonathan.
My name is Jonathan Doneth. I grew up in Syracuse, New York, actually. In high school, I enjoyed, playing soccer and camping. And it's funny. I think back to when I was in high school, and wouldn't say that I like loved math. I feel like in school you're doing school, and so you don't necessarily love all the things you're learning, but I did enjoy it, and I felt like I had a knack for it, that and science. And so when it came time to pick a degree, that kind of was guiding me, and I had some good advice from my dad and some people that I knew, and so I ended up going and getting a mechanical engineering degree, but also got a Spanish minor with that because that was something I was interested in as well. Got that at Geneva College here in Western Pennsylvania. It was a really good college experience, a well-rounded education. And then out of college, I got my first job at the Old City Forge Group as a technical sales representative because I wanted to interact with people more. I was a little turned off from engineering originally because I felt like I just had to kind of sit behind a desk and work on a little, complicated component for a bigger system. So I enjoyed the sales experience. It was good to interact with customers, see where our products were going. And then bringing that perspective in, I became a quality engineer, which is where you actually work with the operators out on the floor. You work with suppliers. Basically, my job was to help make sure things keep going smoothly in production, and when issues come up, help find resolutions for those. So that's kind of tying back to the math. In math, you're learning about problems and how to solve them. Well, when you get an engineering degree, they kind of teach you how to take that into real world applications, and then quality engineer, you get to apply that in manufacturing and solving problems as they come up. So I had a good experience there, but was looking to kind of advance my career a little bit. And was looking for a change. So I ended up getting a job at MSA, Mine Safety Appliances, and that's where I currently work. So at MSA, I get to work with the portable gas detection equipment. So I have a few pictures here. I threw a bunch of pictures on there. Starting up in the left-hand corner here, like the left side of this slide, is kind of what happens here at MSA. We get raw materials in or components in from different suppliers. And we take those components, we manufacture some circuit boards and sensors in-house ourselves. We take all of that and we assemble it together, put it together. We take all these things that are pretty useless on their own. We assemble it together into these products you can see up here in the right-hand corner. We make a lot of different products, but these are the products that I get to work with personally. All of these are used for detecting gases that could be harmful to people. So Mine Safety Appliances is all about safety equipment. And so I threw a few pictures in there of different applications where our products are used. You can see here firefighters. If you've ever, I don't know if you've ever had the fire department called to your house for a carbon monoxide call. They use our equipment to detect that gas, which can be very dangerous. Construction, they use it in, before they go down into a sewer or something to check the gas levels to make sure it's safe for a worker to go down there. And then miners, most people down in mine now are required to be wearing some sort of gas detection device, because if they are mining and they release a gas in the ground, that could be deadly. So they need to know right away. So you can actually see on this guy's belt here, he's wearing one of our Altair 4XRs. So that's about me, and this is what I get to work with. So thank you.
All right, thank you, Jonathan. Next we have Jake.
Hey everybody, thanks for the opportunity to share this morning. I'll also get my screen going here. I have just like a couple of slides. Where are those? All right, I guess you guys can see my screen and hear me, correct?
Yep.
All right, nice. So yeah, my name is Jake Widener. I work here at Bayer at the Indianola, Pennsylvania site, just northeast of Pittsburgh. We are a pharmaceuticals manufacturing plant and also do a lot of R&D. A lot of other business functions are here. This is one of 3 sites we have in the Pittsburgh area, which I'll talk to that a little bit more. Right now, I work on the engineering team, although I have more of a digital and IT type of role. I spent 3 years with Bayer IT before I wound up on the manufacturing side. So I get thrown into a lot of fun digital IT and OT type of projects. I'll just try to give you guys a quick idea of what we do here based on our final products that we make. So we are a radiology company, or a radiology division of Bayer. So we actually manufacture sterile disposables and injectors that are used in things like CT scans and MRIs. If you're familiar with those type of operations, you get like a contrast fluid pumped in your body so that the radiology machines can like pick up better images from those scans. So I'm not an expert in that at all, but I just wanted to give you an idea of what we make, what the final product looks like. So yeah, I just wanted to give you an idea of our 3 sites here in the Pittsburgh area. We have our O'Hara site, which is in RADC Park, just off Route 28, northeast of Pittsburgh. That's where we actually make our injectors, and it's all hand assembly. Very, very large operation up there. We also have our Indianola plant, which is where I'm at. This is our launch site, or like kind of a lot of our business functions are here too. We have a lot of different products we manufacture. So we're more of a low volume, high mix manufacturing site as well. And then up in Saxonburg, Pennsylvania, which is near like Butler and Cranberry, that's where our high volume manufacturing plant is. It's highly automated, lots of robots and really cool equipment up there. And we crank out millions of these syringes and disposable products to go and work hand in hand with our injectors at that plant. So that's an idea of our operation here. How I got here, I have to thank our guys at Hamill because I was actually in the Navy on an aircraft carrier. So, thanks for keeping us afloat there. I did that right out of high school and ended up using my GI Bill to go to college at LaRoche College, which is in the Pittsburgh area here. I have an MIS degree, Management of Information Systems degree. Turned that into an internship at Bayer IT in Pittsburgh, and now I wound up on the manufacturing side. So that's a real quick background for me. Thanks for having me, guys.
All right, thank you so much, Jake, and also thank you so much for your service to our country. And lastly, we have Kara.
I also have Emily Thurston joining me from Pressure Chemical, so she can do a little bit of an introduction on herself as well. My name is Kara Champion. I am a process engineer here at Pressure Chemical. I've been here since I graduated college from Pitt back in 2016. I started out as an intern post-graduation. I actually reached out to Pressure Chemical during my sophomore year of college. I had to interview somebody in my field, and my dad had actually met Emily a few years prior to that and took her business card because I was a freshman. And I came toward the facility. Fast forward a few years later, and the CEO had reached out to me to come and have an opportunity with him post-graduation. So I do process engineering work and recently transitioned into project management, which I love. We get to work with various companies. We are a service provider, so we make few products, and we more so help people optimize processes that they have for their own products. If they have a process at a lab scale, we help scale up and kind of work with them with that. Emily, if you want to introduce yourself.
Sure. So I'm Emily Thurston. I share a similar background to Kara in regards of I'm also a chemical engineer from the University of Pittsburgh. I'm a transplant to Western PA, so I'm one of the few that has joined rather than stayed. So I actually grew up in the Poconos in Pennsylvania. So the university was an opportunity for me to kind of pursue, my engineering path because of, I had this enjoyment of the technologies and the sciences. During school, I was able to participate in the cooperative education program that the university had. So I actually was a repeat intern at Hankook Tires, where we did both rubber compounding. It was a technical center, I did work with a group that was doing finite element modeling. So we got involved in doing, more computing-based information, and also doing industrial research in terms of what is our competitors doing in the marketplace versus what they were doing. So a very interesting experience where you got a lot of hands-on application in the midst of going to school, which I highly recommend to people that are going to school for any of the engineering disciplines, to see what you like and what you don't like before you get out into the field. Sometimes that's a really important evaluation when you go to look for jobs later on. Directly out of school, I decided to go to a startup company. So I was doing a little bit of everything from analytical development, purchasing equipment, installation, and starting up a chemical plant that was making polyphosphazine rubbers. In that process of having that position, I did meet Pressure Chemical, and I made a career change where now I'm doing more of the business side. So I've been a technical sales manager here, and in 2017, I took on a higher level sales role where I lead our sales group, and I'm the director of sales here at Pressure Chemical. For a little bit about us, we're mostly a service company to the chemical industry. So we do manufacture chemicals here in Pittsburgh. Probably the thing that we are least known for, but is probably the most outward facing, is we make cholesteric liquid crystals. So if anyone's ever seen a mood ring or a thermometer that changes color with temperature, we make the base chemicals here in our facility in Pittsburgh that go into those type of applications. But the vast majority of our efforts here are doing process development, pilot scale up, and contract repeat manufacturing for the fine chemical industry. And there's a huge variety of companies that we interact with, everything from pharma, petrochemical, electronics, paints and plastics, lubricants, additives. So in that regard, it's pretty interesting because we have a really diverse view of the chemical industry, since we're a service rather than just manufacturing a specific product line. And then to give a quick view, because I know sometimes a picture is worth 1,000 words, and this is the world Kara's living in way more than me at this point. This is just a quick view of two different areas in our facility in terms of, we really do chemical operations. So we're looking at reactors and centrifuges and dryers and things like that. So this is kind of the world that we live in on the chemical side. Kara, do you have any more you want to add?
No, I think our company is really unique in the sense that we assist so many other companies figure out and solve the problems that they have, that maybe they don't have the capabilities internally to solve those problems. And from a project management perspective, I get to work with the client and the sales team from the very start of the problem and help develop the process, what that may look like, and help them solve whatever they need. It's something different every day, which I really appreciate.
Yeah, and I think that the first introduction really spoke to that, where I think it's a core value of our company, and something we really look for in our employees is having that growth mindset to be able to get involved, because we've got a lot of different backgrounds. They're not always science backgrounds that support our operation on the operator level. But we really value that diversity and what they bring, because we're really looking for problem solvers is kind of the key thing. So thank you very much.
All right, thank you all for those introductions. Now, kind of moving along, I know you've all kind of touched on this in a way, but something that's always been of interest to me and potentially to students that might be looking to get into this sort of a career. What makes your job cool? What might aspire students to do what you do? And I'm just gonna call Jake.
Nice. I was
Sorry,
ready
Jake.
to go. You knew. I would say what makes my job cool, being in like pharmaceuticals and medical manufacturing, is knowing that the end result of what we do here is that like people's lives are saved, right? Like without these MRIs and CT scans that are performed using our products here, people wouldn't be catching things like tumors or whatever, right? Like people would die. So it's kind of cool to know that we provide like a really awesome life-saving product to hospitals all over the world. So that's pretty cool. I also think personally that anything automated and robotic is just awesome. I enjoy just standing near our machines and just watching how all the little pieces move on their own, and how we take over our raw materials and get final products. So I think that's manufacturing in general. I just think it's awesome though.
All right. How about the Hamill crew? The naval defense was certainly very interesting.
I think what's cool is, the criticality of our components. You get a lot of satisfaction that they're installed on the aircraft carriers and submarines that protect our nation's security and our freedoms. Same thing as Jake. I find it very satisfying to go down and see the raw material being processed, chips coming off the part, and seeing something from a piece of paper or a drawing be transformed into a finished part.
Yeah, I would echo a lot of what Scott said there. Just given the nature of what we make, we start with a large hunk of material and we take it to a finished part. And given the components we make and the way our contracts are structured, that takes sometimes a couple years. From the time we get an order from our customer, from the time we ship a finished component, it takes a couple years. It takes several months to get the raw material from who we buy it from. And then it takes equal, if not more time for us to take that raw material and process it, whether it's machining it on our CNC machines, welding it, or a combination of both, and then turning that into what you see on the customer's print, and finally shipping it. And oftentimes, and as Scott had mentioned, more times than not, actually, when we ship these parts, they're going to Newport News, which is the shipbuilder in Virginia. So these parts are going right into an aircraft carrier or submarine. So that's very satisfying. You get a sense of accomplishment after a couple year project leaves out the door, and you know where it's going to go and what it's going to do for the next 30, 40, 50 years on a boat.
Yeah, certainly. Kara and Emily.
I would say my job is really cool because I get to do something different every single day. We work with different industries, so it could be, like Emily said, cosmetics, adhesives, aerospace, really a variety. And knowing that they have a problem and we are a key component to solve that problem is really fascinating. And maybe what we're working on may not make it to marketplace for 10 or 15 years, but knowing now that I'm a part of something that other people will see later is really great to be a part of.
Yeah, I have to agree. I mean, we get to work with the leading companies in our fields. And I think from that perspective, that blended with the diversity of it's always different. I'm one of those people that I enjoy the riddle. I enjoy the challenge of taking on the new of these projects, because like she said, a lot of times we're on that initial starting level where this is the development work. This is the initial commercial quantities that people are going to use to decide, is this a new technology that they're going to apply to industry? So I think from that perspective, it's been really fascinating. That and just seeing the fact that like we have a tool and that tool is supposed to do one thing, and the people inside of our building have figured out how to do 3 or 4 things in that tool that was designed to do one. A good example of that is we have a dryer, but I've seen them use a dryer to filter things, which is not like the go-to, hey, that's not even what that, is called as an item. So I think that the problem solving and the skill set that we get to see and the experience we get to learn from internally, because Kara and I are in the younger crowd in our company. She's much younger than I am. But from that perspective, I think that it's been really, really neat and interesting to come to work because of those aspects.
Absolutely. Thank you. John or Anthony?
Yeah, I really enjoy what I get to do. Actually, I was just thinking about this last week or 2 weeks ago. I was having a really hard week. We were having some issues that we having trouble resolve, and I was leaving work late one day and I realized like I still enjoy what I'm doing right now. And it's because like several reasons. One is just the satisfaction of solving problems. So we'll have issues that come up out on the floor, and it will shut a product line down or something, and you have to dig into that and figure out what's going on. It's usually, nobody's usually coming to you saying like, hey, we need to fix this. It's, hey, something's not working. And then you have to kind of dig into that and figure it out. And the other side of it is kind of like what they're talking about with Hamill, over at Hamill, just the satisfaction of the products. We get to build these parts. I get to see them finish complete before they go out the door. And the next person that's going to be picking that up is a firefighter or somebody out in the field in industry or mining, and their lives are depending on these things. And we're by providing these products to them, we're allowing them to go to work and come home every day and not have to worry about, getting poisoned by some gas or something. And on a personal note, I am a volunteer firefighter. And so I actually get to see MSA's products used in action, because they also build like the SCBA, the air packs, the breathing apparatus, the helmets, all of that stuff for firefighters. So I've actually got to see that in use serving the community. So I really enjoy what I do here.
I think my job is cool because it's like a real life how it's made. I'm sure a lot of the panelists here have seen the How It's Made TV show, but I always found that fascinating watching that with my father when I was a child. And now I get to go into these manufacturing facilities, a bunch of different ones. I get to see the processes that they have, the machines that they have. I like the problem solving aspect, as a lot of people mentioned. You're there until the thing that you're working on works correctly. So you have to be creative, and sometimes you can feel like the stakes are a little high, but generally, you give everything your best effort, and it usually works out. Yeah, and that's one really cool thing about my job.
Well, thank you all. It's certainly worthwhile having a job that's, very rewarding and inspiring, and then you enjoy going to every day and feeling you're making an impact. Now, for students that might be considering careers in manufacturing, and I'll open this question to the floor, what are companies looking for in terms of talent and skills, or where do you see the biggest gaps in talent?
I'll jump in. It's interesting. So we work with a lot of different types of people, either in the office or out on the floor. But most consistently, what I've been seeing is just managers are looking for people with a passion and a drive to solve problems and collaborate with other people, which is interesting because it's not necessarily, that's not a hard skill. That's a soft skill. But they're looking for those people that are interested in what they're learning, because people that are interested in what they're learning are asking questions about why it works, and they're trying to understand the how behind it. And they're willing to talk to other people and try to get those answers to why and work with others. So I think those soft skills of problem solving and collaborating and being interested in what's going on, that's huge. I mean, that's something that you students, you guys can work on. You don't need to be in a classroom to work on that, but you can work on it in the classroom. You can work on it with your family and friends, is just being that interested mind who's willing to dig in and do the hard work.
I also agree with John. Problem solving is huge at our company. Thinking outside the box. Don't be afraid to share your ideas. And this was something that I struggled with right away, was sharing my ideas. Maybe I thought that they weren't the best, and once I shared them, people were happy with hearing my thoughts. Don't be afraid to ask questions. I think we appreciate having an open mind, a different perspective on things, and just really diving into trying to solve the problem.
I think John and Kara hit the nail on the head there. Also, what I'd like to add, obviously in Hamill's realm, we would ideally like new applicants or new employees to have a understanding of manufacturing in a generalized sense. So what can you make on a lathe? What can you make on a mill? What different processes do you have to go through to yield a finished part if you're starting with a round piece of material. That's fairly obvious what we would need. Behind the scenes, and kind of to build on what was already mentioned there, we want people that are hired that what I'll term are willing to hustle. Ask the right questions, be involved in understanding why we have to do things the way we do. Don't be afraid to ask questions or bring ideas to the table. The willingness to go above and beyond just the bare minimum of a 9-to-5 role is what we're really looking for. We want people hungry to learn, hungry to work hard, and like I said, to hustle when we have to. You're never going to learn everything you need to in a tech school when it comes to machining, especially when it comes to parts specifically to what Hamill makes. A lot of intricacies go into that, just given the size and some of the quality requirements that are behind that. But always be willing to learn, always be willing to ask questions, and devote yourself to growing as an individual.
Yeah, it's too easy to just echo what you guys are all saying, because it's 100% true. But I'll also throw in, at least here at Bayer, we're always hiring a bunch, anybody from a bunch of different backgrounds. I mean, right off the top of my head, maybe mechanical or electrical engineers, IT people, supply chain experts, equipment maintainers. There's a lot of different needs. If I were to say the biggest technical need right now that I can think of is more so PLC, automated equipment, operational technology type of folks. So that's at the very moment. I mean, that's subject to change. But yeah, I almost more importantly is just, we're looking for people that are willing to work hard and can work with the teams here. So yeah, echo everything you guys said.
I would like to echo again everything that everyone said. All those skills are all very important, but a general piece of advice that I would give to a young person, if you know some type of field that you're interested in joining, there's always extracurricular opportunities to get some experience in that field, whether it be different clubs in your high school or different clubs in college. I think it's important that you put yourself out there and you try the things that you're interested in. And that also shows that you are motivated, you're really interested in this field, and you can also determine if something isn't the right fit for you. And if maybe clubs and those opportunities aren't the right thing for you, you can also, show your interest by doing self projects. I know people that build their own 3D printing machines. That isn't necessarily a club, but it definitely shows that you have an interest in electrical engineering. I know it's a more advanced example, but whatever you can do.
Great, thank you all for that really sage advice. We only have a couple minutes left in this segment, so I think time for one more question. Kind of, you had mentioned getting involved and kind of seeing what you're interested in. So real quickly, again, this is an open floor question. What technology fields do you feel are growing the fastest that, students might be able to get involved in, kind of see if they like that group?
I know for us here, we're pushing more and more into automation. So robotics and automation is huge. I can leave it right at that. It's very, easy answer.
Same thing here at Hamill. Robotics, not that we have a whole lot of robotics here just because we're a low quantity shop, but a lot of manufacturers are leaning towards robotics. Another thing is 3D printed parts. 3D printing allows shapes and configurations to be made a whole lot easier than your typical or traditional tooling and machining centers can produce.
Yeah, one additional item there that may relate better to our audience here in high school, and if I think back to my high school days, get involved in the CAD classes, whether it's AutoCAD or Inventor or SolidWorks. Get involved in those classes, because those softwares go hand in hand with a manufacturing facility such as ours, because a lot of times our customers develop, and the design engineers that that work at our customers develop the 3D models, and they will provide those to us. And we have specific software that we use to write code that our machine tools can then follow to machine these parts. So having understanding of the technology behind that is definitely where manufacturing is going. The machine tools nowadays resemble much more of something you'd see in a science lab rather than a dirty, dark manufacturing facility. They have controls on them that mimic laptop computers. So technology definitely needs to be embraced from the get-go.
I think another element of that, because I mean, obviously automation and robotics, I think that was the first thing that popped into my head. But when I try to think about what are the other areas where we're seeing a lot of technology come and really be pushed, and a lot of it's like, you know, cost saving, it's driven by the sales side. So you get a lot of backing when that happens, is things like ERP systems like SAP or Oracle-based systems, where they're doing logistics and shipping management. Because I think they're pulling into a lot of that as well, because it goes hand in hand. If you make the part, you need to know what it costs you to make it, where you're shipping it, when it's going. And we're even seeing in some of those applications, interconnections now between companies where you can link your SAP to somebody else, and you know that can be your interaction. So they're trying to streamline a lot of processes. So I think, you know, in general, a lot of computing and IT. But I think the applications of that are pretty varied, whether it be in, you know, the tried and true manufacturing, whether you're doing, you know, 3D printing, milling, lathing, those type of operations, or when you think about it on a little bit more of a, you know, a desk basis where you're not touching all those parts, but you're figuring out where they are, you know, using that type of computing power.
I think that, I mean, you can't go wrong these days with going into the electrical side of things or the software side of things, like they were saying, you know, IT and anything electrical. Like I like what they're saying over there at Hamill about getting into the CAD and just the computer programs that are used for making 3D models, 2D models, even getting into programs like Excel, which is a way more powerful tool than you'd ever realize in high school. We're still using Excel, you know, many of us, and there's a lot of features there that you can learn, but don't let any of that dissuade you. I know for me, I was a mechanical engineering major, and nobody talks about mechanical engineering as much as electrical and software, but it's all about learning a diversity of things that can be just as helpful as learning one specific thing like electrical. I know I was hired on here, even though we do a lot of electrical stuff, just because I had a kind of a diverse background and an education that would, you know, didn't just focus on mechanical. But on the mechanical side, robotics and all of that, there is a, you know, everything has to move. You could have all the electrical and IT people in the world, but you need a mechanical engineer to actually make things move. So just any of the technical disciplines, really, you can't go wrong there right now with how everything's going.
Well, thank you all so much for your insight. Definitely very, very interesting to hear all of your stories and to learn a little bit about you, each of you and your companies. And I think you've given, you know, students who are listening today definitely a lot of very good advice and, you know, certainly interest in the manufacturing field. So thank you very, very much. I think now we will be moving on to my colleague, Steve Leonard, who is the Programs and Operation Manager for the Digital Foundry and Nextivation. And I think, Steve, you'll be telling us a little bit about the Digital Foundry here in New Kensington.
Yeah, that's correct. Thank you, Alyssa. And thank you to the panelists for giving a really good session explaining you know, their paths in manufacturing and their careers. I think it was wonderful. My name is Steve Leonard. I am the Operations and Program Manager for the Digital Foundry, which is part of Penn State New Kensington. It's a new initiative that has been started to help local manufacturers and businesses in manufacturing specifically, but also other businesses, as well as to provide workforce development training. So I'm going to give a little bit of just a quick overview of what we do to kind of wrap up this session, and we'll go from there. So let me share my screen. Everyone can see that? Okay. So the Digital Foundry was founded about 2 or 3 years ago, as far as an idea developed by Penn State New Kensington as a means to be able to reach out and help this particular area around Kensington. It's a bit of a depressed area that has some social and economic challenges, what we would call a Rust Belt town. And we wanted to be able to help set up a facility that could work in workforce development to help people develop into new jobs in the manufacturing area, as well as help local business and industry, specifically in manufacturing, in their transformation into digital manufacturing. So this is our team. I'm going to just go quickly through it. Sherry McCleary is our executive director. Myself, whom I've introduced. Vince Petrelli is our senior manager of project technologies, and Alyssa Pistonenzi is our business operations manager. So our vision is to improve the lives and strengthen business through access to digital technologies, something that we recognize is not happening as prolifically as we would like to see, not only in this area, but in the country. So we feel that this is an important mission. We want to really drive ideas and learning and problem solving through the application of these digital technologies. So through education and workforce training, manufacturing competitiveness through technology demonstrations and proof of concept, as well as networking of businesses, academic community, as well as the regular community together. So we're all sort of kind of unified in helping the community thrive. And our values really are around innovation, continuous improvement and learning, collaboration, and equitable access for everybody, because we believe everyone needs to have access to these wonderful technologies. So our facility is currently under construction. It's a 15,000 foot square facility for digital learning and a small makerspace down in digital area down in New Kensington. It opens sometime in April of next year. And we've been supported through the support of the R.K. Mellon Foundation and partnership with Economic Growth Connection of Westmoreland. So this gives you an idea of these are computer renderings of what the facility will look like. It'll have classrooms, collaboration area supporting learning, meeting spaces, as well as a computer lab and a bay with software and hardware systems that we can actually demonstrate. So programs and services, I said, are really around a three-prong approach, which is education and training, conducting events and getting these concepts exposed to everybody. That's businesses, industry, the community, the academic institutions in and around the area, not just Penn State New Kensington, as well as with benefactors and people that want to invest in the area. And then we have industry projects where we try to help local businesses and industry. And local is to the region of southwestern Pennsylvania that we want to focus on to be able to help them solve their problems in digital manufacturing, how they're going to transition into digital manufacturing. It's something that we recognize as a need. Not as many companies as we thought are really getting into this space, and they need to be competitive. And we're talking about things like automation, robotics, using the Internet of Things through what we call the industrial Internet of Things, sensor technology. A lot of it is couched and really built in the basis of data and programming and a lot of computer interaction to be able to help capture that data. And we're getting into things that we'll talk about artificial intelligence and machine learning. So we really have a number of prongs that we outreach to the community, such as speakers and conferences, demonstration and workshops, business networking for the businesses, job fairs and student engagement, which is a very much an important part of what we do, and in K through 12 and educator outreach. So we partner very closely with ABC Create as how we're going to roll this out. So the levels of training that we offer really span a broad spectrum in the manufacturing workforce, from fundamentals for those looking to enter manufacturing, what we call level 1. Level 2 is really upskilling of the current shop floor, digital in manufacturing for shop floor and supervisors, exposing them to things that will enable them to operate digital manufacturing tools and capabilities, all the way up to advanced digital manufacturing applications, such as programming and simulation, working around topics like digital twin, which is essentially leveraging computer-aided design, computer-aided engineering, computer-aided manufacturing to be able to help become more competitive and effective in manufacturing products. So we like to use a really nice, well-rounded program of hands-on learning, which I think is very important, and guest speakers from industry and so on. For demonstration projects, we really like to work with manufacturers to sort of kind of understand what their needs are through an interest and an awareness session, try to discover some of the challenges that they have, and work with them through solutions identification, and then projects and demos that we would be able to offer for them to kind of prove out their concepts in a way that they can then take that and go to the various companies and partners that might be able to offer these technologies for them. We're a nonprofit, so we're not here to do projects for our own benefit, but for the benefit of manufacturers. So we partner with industry leaders to provide solutions in a variety of different spaces. As you can see in the green check marks, we cover a lot of different areas based on the experience of our team, all the way from CAD design down to advanced controls and automation and into advanced robotics. Eventually, we'll get into augmented and virtual reality. We had talked about that yesterday with some of the students working on their virtual reality spaces, but it all boils down to business value, which is productivity and agility, predictive maintenance, uptime and utilization. And it's very heavily based in the area of data, software, equipment, where software meets hardware, and really advancing where manufacturing is going. So it's going to be utilizing a lot of these technologies to be able to help our local businesses and industry be competitive. So we have technology partners we're working with that have been actively involved in what we're doing. As you can see, we have Premier Automation. So having Anthony join us is really wonderful on the panel, but a lot of companies that are looking forward to working with us to kind of help our local manufacturers and our local businesses. So to wrap up, I want to thank you very much for your time today. The digital manufacturing is a really hot growing space for what we do in the manufacturing arena. And on behalf of the Digital Foundry, Sherry McClary and myself, we want to thank you for participating in our panel. And thanks to Catalyst Connection for helping to organize and arrange this.
All right, thanks, Steve, and thank you so much for kind of giving an overview of what we're doing here in New Kensington. And to echo Steve's sentiments, thank you very much, Scott, and your team at Catalyst Connections for partnering to put this program on today. I think we also want to thank our panelists for joining us today: Dave and Scott, Anthony, Jake, Kara, and Emily, and Jonathan. I think with that kind of wraps up the National Manufacturing Day activities.